Hello, NK Fantastic fans, and welcome back to the channel where we ask the biggest, wildest, and most terrifying what-if questions in the universe. I'm your host, and today we are tackling a scenario so catastrophic, so utterly world-ending, that it makes asteroid impacts look like a minor inconvenience. We all feel it, but we never think about it. This gentle, reliable spin of our planet. It gives us our day and night, our weather patterns, our very rhythm of life. But what if, for just 30 days, that rhythm stopped? What if the Earth, right now, just slammed on the brakes? Not a gradual slowdown over millions of years. An instant. Full stop. Well, grab onto something solid. Though, as you're about to find out, it really won't help. This is... What if the Earth stopped spinning for 30 days? Chapter 1. The Great Scrape. The first thing you need to understand is speed. Right now, if you are sitting near the equator, the Earth is spinning you. Your house, the air, and the oceans at a blistering 1,670 kilometers per hour. That's about 465 meters per second. Faster than the speed of sound. Even here in a more temperate latitude, we're still cruising along at a cool 1,200 kilometers per hour. We don't feel this speed for the same reason you don't feel 100 kilometers per hour on a smooth highway. Everything, the car, you, the air inside, is moving together as one unit. Now, imagine that car at 100 kilometers per hour hitting a solid concrete wall. The car stops. But you, thanks to a wonderful little thing called inertia, do not. You keep going. This is why we wear seatbelts. When the Earth stops, the solid planet stops. The crust, the mantle, the core, it all locks in place. But you don't. Neither does your dog. Neither does your house, the trees, the topsoil, the atmosphere, or the 1.3 billion cubic kilometers of ocean water. Everything on the planet's surface that isn't nailed down to the bedrock becomes a projectile. And not just a projectile, but a supersonic one. In the first second, every human, every animal, every car, and every building would be instantly flayed from the surface of the Earth. You wouldn't just be thrown. You would be launched horizontally at over 1,600 kilometers per hour. You would, for a fraction of a second, be the fastest human being who ever lived, just before you and everything else are torn apart by the sheer frictional forces. This isn't a tumble. It's an instantaneous transition into a high-velocity plasma of, well, former stuff. The Great Pyramids, the Rocky Mountains, the Himalayas, anything with deep roots into the crust might survive the initial stop, but they wouldn't be recognizable. They would be scoured, as if by a planet-sized belt sander, by a horizontal blizzard of what used to be cities, forests, and topsoil. We wouldn't even have time to register a thought. The event would be over for humanity before our own nerve impulses could travel from our feet to our brain to tell us something was wrong. It is the most mercifully quick apocalypse imaginable. But our story doesn't end there, because for the planet itself, the horror is just beginning. Chapter 2. The Apocalypse Wind. While the solid stuff has been scoured away, we have another problem. The air. The atmosphere, that gentle blanket of nitrogen and oxygen, is also moving at 2,600 kilometers per hour. And like the oceans and the buildings, it is not rigidly attached to the planet. It's held by gravity, but it has its own momentum. When the solid Earth stops, the air keeps going. This would trigger a global, supersonic wind. A wind so powerful it has no precedent in Earth's history. It's not a hurricane. It's not a tornado. It is the entire Earth's atmosphere turning into a single, planet-scouring blast wave. This wind would circle the globe, unimpeded. The friction it would generate against the now stationary ground would be unimaginable. It would be like striking a match on every square inch of the planet simultaneously. The sheer friction would heat the air to incendiary temperatures. This wind would not just push things, it would ignite them. the remaining fragments of cities, the roots of forests, any organic matter left, all would be consumed in a global firestorm. This superheated, supersonic wind would also cause erosion on a scale that defies geology. It would strip the land down to the bedrock. It would blast mountains and carve new canyons in a matter of hours. The sound alone would be a continuous, global, deafening sonic boom. A planetary scream so loud it would physically shatter any rock that had survived the initial scrape. Within the first few hours, the atmosphere itself would be fundamentally changed, cooked by its own kinetic energy, choked with the ash of a pulverized world. And then there's the water. Chapter 3. The Tsunami to End All Tsunamis. You thought the wind was bad? Let's talk about the oceans. The oceans, like the atmosphere, are just riding along. They have unfathomable mass and unfathomable momentum. When the planet stops, the oceans do not. This wouldn't be a tidal wave. This wouldn't be a tsunami. A tsunami is a displacement of water. What we're talking about here is the entire ocean sloshing forward at 1/1600 kilometers per hour. It would be a single, globe-spanning wave, kilometers high, moving at the speed of a rifle bullet. This wall of water would scour the continents clean of everything the wind and the initial inertia scrape left behind. It would crash over the Andes, surge over the Himalayas, and not stop until it met the tsunami coming from the other side of the continent. No landmass, no matter how high or how far inland, would be safe. The continents would be subjected to the most violent washing machine cycle in cosmic history. The sheer pressure and force of this water would pulverize bedrock, grinding mountains into sand in an instant. The planet would, for a time, become a true water world, but a boiling, churning, chaotic one. But the water wouldn't just stay in this chaotic state. Because in stopping the Earth's spin, we have broken a fundamental law of the planet's shape. Chapter 4. The Great Migration, the New World Map. Why is the Earth round? Gravity. It pulls everything in toward the center. But why is the Earth not a perfect sphere? The spin. Our planet is technically an oblate spheroid. It bulges at the equator. This equatorial bulge is a direct result of centrifugal force. The planet's spin is constantly trying to throw its guts out into space, and this force is strongest at the fastest moving part, the equator. This spin-driven bulge means the Earth is about 42 kilometers wider at the equator than it is from pole to pole. This bulge also affects the oceans. The spin piles up water around the equator. There is a literal 8-kilometer-high bulge of water at the equator that is held there purely by centrifugal force. When we stop the spin, that force vanishes. Gravity, which has been patiently waiting, now takes over completely. And gravity wants only one thing: to pull everything into a perfect sphere. The 8-kilometer-high bulge of water at the equator, no longer held in place by spin, will begin to move. It will collapse, seeking the new lowest point. And where are the lowest points on a non-spinning, perfectly spherical Earth? The poles. After the initial chaotic slosh, a great migration of water will begin. The oceans will drain away from the equator and flood the poles. This wouldn't be quick. It would be a slow, massive, and unstoppable process taking days or weeks. But the end result would be a brand new world map. The world would now consist of one single, massive supercontinent wrapping around the planet's equator. We could call it Equatoria. It would be the collected land masses of North and South America, Africa, Asia, and Australia, all fused together, now high and dry. And at the top and bottom of the world, there would be two new, unimaginably large and deep oceans, the North Polar Ocean and the South Polar Ocean. These oceans would have drowned the Arctic and the entire continent of Antarctica, and much of what used to be Canada, Russia, and Northern Europe. The Earth would now be a ring of land separating two giant polar seas. This is the state of the planet on day 2 or 3. The initial violence is over. The survivors? 0. Absolutely none. Not even bacteria on the surface. But the prompt said the Earth stops for 30 days, which means our catastrophe has 2 more acts. Chapter 5. The Long Day, the Scorch. We just broke the day-night cycle. Before, the Earth completed 1 rotation on its axis every 24 hours. This is our day. But the Earth also orbits the Sun. This takes 365 days. If the Earth stops spinning on its axis but continues to orbit the Sun, we now have a day that is 365 days long. One side of the planet will face the Sun for 6 months. The other side will face the frozen darkness of space for 6 months. The prompt, however, gives us a 30-day window. So let's look at what happens in those first 30 days. Half the planet is now locked facing the Sun. Let's call this sun side. Half the planet is locked in darkness. Let's call this night side. And separating them is a thin, permanent twilight zone, or terminator line. Let's visit sun side first. On day 1, the temperature is, well, whatever it was when the world ended. On day 2, the Sun doesn't move. It just sits in the sky, in the exact same spot. On day 3, it's still there. On day 4, the temperature is climbing. On day 10, the great migration of water is complete. The vast equatorial continent is now a dry, baked desert. The oceans are gone, hiding at the poles. The relentless, unmoving sun beats down. The temperature climbs past 50 degrees Celsius, past 80, past 100 degrees Celsius. Any remaining water on the continent's surface, lakes, rivers, boils away, creating a thick, temporary humidity that is quickly cooked out of the atmosphere. The land itself begins to crack and superheat. By day 20, the sun side of Earth is a Mercurian hellscape. Temperatures on the equatorial continent will reach 200, 300, maybe 400 degrees Celsius. Our lead would melt on the surface. The ground itself would glow a dull red. The remnants of the wind-blasted, tsunami-scoured mountains would bake and crack, exfoliating rock under the thermal stress. The atmosphere on this side would puff up, expanding massively under the heat. Sunside is now an oven, a lifeless, sterile, continental-sized brick oven. Chapter 6. The Long Night, the Deep Freeze. Now, let's walk across the terminator line into the night side. Here, the sun has set, permanently. On day 1, it's dark. On day 2, it's dark, and it's getting cold. On day 5, it's really cold. Without the sun's warmth and without the spin to distribute heat, night side is now radiating all its warmth into the blackness of space. The temperature plummets. 30 degrees Celsius. 50. 100. By day 15, the night side is so cold that the atmosphere itself begins to change state. Carbon dioxide would freeze first, snowing out of the sky as a blizzard of dry ice. By day 20, the temperature drops further, approaching 180 degrees Celsius. This is the boiling point of liquid nitrogen, or, in this case, the condensation point. The nitrogen gas that makes up 78% of our air would begin to rain down as a liquid. By day 25, the temperature hits 210 Celsius. Now, the oxygen freezes. The night side of the planet would be covered in a thick layer of frozen air, mostly nitrogen and oxygen snow. The atmosphere would be physically freezing and collapsing onto the ground, leaving a near vacuum above. So, on day 30, our planet is a creature of 2 faces. Face 1, a scorched, sun-baked desert, hot enough to melt lead. Face 2, a frozen wasteland, covered in liquid nitrogen rain and oxygen snow, colder than Antarctica on its worst day. And this creates one final, continuous weather pattern. Chapter 7. The Eternal Hurricane. What happens when you have a superheated mass of air on one side of a planet and a superfrozen near vacuum on the other? Nature hates a vacuum. The thick, expanded, boiling hot atmosphere on sun side will have only one place to go. rushing into the cold, low-pressure void on the night side. This will create a new, permanent, planetary wind. This wind wouldn't be the initial 1,600 km/h blast. This would be a thermal wind. It would flow from the hot side to the cold side, constantly, across the entire globe. But the most violent spot would be the terminator line, the twilight zone. This narrow strip of land where the sun sits eternally on the horizon would be the most violent place in the solar system. It would be a permanent global hurricane. Winds far exceeding 500 kilometers per hour would scream from the light side to the dark side. On the hot edge of the twilight zone, you'd be blasted by superheated air. As it crosses the line, it would cool rapidly, dumping all its moisture, if any was left, as the most torrential non-stop rainstorm imaginable. Then, as it plunged further into darkness, that rain would turn to snow, and then to liquid nitrogen. The twilight zone would be the only place with a remotely tolerable temperature, but it would be rendered completely uninhabitable by winds that would make a Category 5 hurricane look like a gentle breeze. Chapter 8. The Survivors. Spoiler, there are none. So, let's just recap. Is anyone on the surface alive? No, they were liquefied by inertia in the first 0.01 seconds. Okay, what about someone in a really deep, really secure underground bunker in, say, Antarctica, which is now at the bottom of the North Polar Ocean? Let's say a bunker, buried 5 miles deep in bedrock, somehow survived the initial jolt. It wouldn't. The inhabitants would feel the most violent earthquake in history, but maybe they're fine. They would be safe from the wind, safe from the initial tsunami, but they are not safe from the new map. Their bunker is now at the bottom of a new 10-kilometer-deep ocean. They are trapped. Okay, what about a bunker in the middle of the new Equatoria continent? They survived the jolt. They are safe from the wind. They are safe from the ocean, which is now thousands of miles away. They are safe until the heat death comes. They are on the sun side. The ground temperature above them is now 400 degrees Celsius. They are effectively in a pressure cooker. The rock itself will heat up, and they will be cooked alive in their bunker. What about a bunker on the night side? Same story. They survived the jolt, the wind, the ocean. But now the surface above them is 200 degrees Celsius. The cold will leach into the rock. It will take longer than the heat, but eventually the bunker will freeze, and so will they. What about microorganisms, extremophiles? The tardigrades, the water bears? They might survive the vacuum, the heat, the cold. But they also would have been scoured from the surface by the 1,600 km/h inertia blast. They wouldn't have a chance to prove how tough they are. This event isn't just an extinction-level event. It is a sterilization-level event. Chapter 9. The core of the problem. Thus far, we've only discussed the crust and the surface, but the prompt says the Earth stops. This implies the whole thing stops. The crust, the mantle, and the core. This creates one final invisible catastrophe, the death of our magnetic field. Earth's magnetic field is our shield. It's generated by the dynamo of our spinning, liquid iron outer core. This shield deflects the most harmful solar radiation and cosmic rays. If the core stops spinning, the dynamo dies. The magnetic field doesn't just get weaker, it vanishes instantly. So let's go back to Sunside. It's a 400-degree hellscape, and now, with the shield gone, the sun is pouring raw, unfiltered radiation onto the surface. The solar wind, a stream of charged particles, slams directly into the planet. It would strip away what's left of our atmosphere. The sunside is now being simultaneously cooked, sandblasted by eternal winds, and irradiated by its own star. The night side is a frozen, airless vacuum. This is the state of the Earth on day 30, a perfectly balanced, perfectly dead sphere of two extremes. Chapter 10. The 30-day itch, the restart. The prompt has a terrifying caveat. What if it stops for 30 days? This implies that on day 31, it restarts. This is, somehow, the worst part of the entire scenario. Imagine our dead planet. The sun side is baked to 400 degrees. The night side is frozen to 210 degrees. The oceans are now two placid, giant lakes at the poles. The atmosphere is mostly frozen onto the dark side. The equatorial continent is a sterile, irradiated desert. And now, click. We spin it back up to 1,670 kilometers per hour. What happens? First, inertia again, but in reverse. Anything that was static on the surface is now subjected to an instantaneous 1,670 km/h acceleration. The ground moves, but the frozen nitrogen snow and the dunes of sand do not. A new scrape occurs, this time scouring the planet in the opposite direction. Second, the water. The spin is back. Centrifugal force is back. The two giant polar oceans, which hold all the world's water, are suddenly pulled back toward the equator. This triggers two globe-spanning tsunamis, this time originating from the poles and crashing inward towards the equator. The Equatoria supercontinent is subjected to another continental scouring, as the oceans of the world race back to reclaim their equatorial bulge. Third, the atmosphere. The frozen nitrogen and oxygen on the night side is now spinning. It will eventually rotate into the sunlight. When it does, it will instantly sublimate, turn from a solid straight back into a gas. This would be a gas explosion on a continental scale, triggering unthinkable pressure waves. The half-baked, half-frozen atmosphere would remix in the most violent way possible, as the 400°C hot side and the 210°C cold side are forced to swap places every 12 hours. The restart is not a fix. It's not a "Phew, that was close." The restart is a second sterilization event, one that scours, floods, and explodes the planet all over again. Chapter 11. The Empty Throne. So, what are we left with after 30 days of stasis and one catastrophic restart? The planet is back to spinning. The day-night cycle is restored. The oceans have violently returned to the equator, and the weather will, after a few thousand years, probably settle down. But what's on it? Nothing. We are left with a spinning, wet, rocky planet. But it's sterile. The crust has been scoured, baked, frozen, and scoured again. The soil, the rich organic layer that took billions of years to create, is gone. It's at the bottom of the newly reformed oceans. The planet is a blank slate. There are no trees, no fish, no birds, no people, no bacteria, no tardigrades. It is an empty world. It's possible that deep within the crust, some deep earth bacteria or archaea, shielded from all the surface violence, might have survived. If so, they would be the new Eve, and life on Earth would have to start all over again. It would take perhaps another billion years for simple cells to evolve, another 2 billion for complex ones, another 500 million for them to crawl onto the land. We are not just talking about the end of human civilization. We are talking about resetting the entire 3.5 billion year experiment of life on Earth. Chapter 12. The Unsung Hero. The next time you feel stressed, or the day feels too long, or you're just bored, take a second, feel the floor under your feet, feel the air in your lungs, and be thankful for the most humble, most reliable, and most overlooked hero in your life, the gentle, constant, 24-hour spin of the Earth. It is the engine that keeps our world alive. It is the artist that paints our skies with sunrise and sunset. It is the great shield that protects us from the extremes of our own sun. And it is the one thing we absolutely, positively, cannot afford to lose. Thanks for watching, NK Fantastic fans. If this story didn't completely pulverize your sense of security, let me know what if we should tackle next in the comments below. Until next time, keep questioning.